Okay, so do you remember we talked about some properties of the right angle triangle before, especially the median? Do you remember that we proved that the median that you draw from the right-angled right-angled angle of the triangle to the hypotenuse, it is equal to the half of the hypotenuse. And then using that, we were able to show geometrically, not using trigonometry, to show that. So let me just repeat these two. So we learned in the previous session that if I have a right-angled triangle with this corner to be 90 degrees, if I draw the median is a line that connects this vertex to the midpoints of the hypotenuse, this median. We'll realize that the length of this median is half of the length of the hypotenuse. So this means that we learn that this line segment has the same length as this one, has the same length as this one. This is the very important property of the right-angled triangle. Okay, using this idea, we were able to show that if I have a right-angled triangle, yes, whose one of these acute angles is 30 degrees, we also showed that the length of this one, this side, which is opposite to the 30 degrees, is still, again, half of the hypotenuse. Of course, you could use trigonometry. It would be very simple because we already know what is sine of 30 degrees. But we realized that we can also solve this problem without using any trigonometry at all. Yes. So these are the things that we actually discussed before. Now, let me, I remember that I gave you this problem to think about. But if you haven't thought about that, we can actually think about it here. So what is the problem here? If one of the acute angles in a right-angled triangle is 15 degrees, show that the measure of the altitude to the hypotenuse is a quarter of the measure of the hypotenuse. Yes. So I don't know how many of you have thought about this problem. Have you? If you haven't, because I can start solving the problem, and then when you see the solution, it becomes easy. What I want you to practice a little bit about your geometrical skills. Okay, so let me give you a little bit of time so that you can think about this problem yourself, and then I will interfere to try to solve the problem together if you cannot solve it. Okay, so let me just pause the video here. Okay, so let me probably start writing something and give you some hint, and then you can think about the problem again. Okay, so this is my right angle triangle. If I can draw it reasonably good. Yes, let us see. Yes, it's good, more or less. And then this means that I am assuming that this angle is supposed to be 15 degrees. Yes, so this is 15 degrees. And then, as I told you, I want to draw the perpendicular line to the hypotenuse coming from here, the height corresponding to this. Yes. And my goal is, this is 90. I'm assuming that this is 90 from the beginning here. This is the height. And then I already know that this angle is also 90. So this is also is 90. So then what I want to show is this. I know that this is A. I know that this is H. What I want to show is that, let me give the names here, B and C. What I want to show is that AH, the length of AH is a quarter of the hypotenuse itself. So that is the question mark. Any one of you come to some idea? Okay, so I think
we should begin by drawing a midpoint between B and C.
Yeah, I think that's a good idea. So the way that I was also thinking about the problem was this. So it means that, roughly speaking, this is the midpoint. And so we say that we draw the median, and then you need to use somehow this to be able to show that this is indeed the case. Yes. So this is added to the problem. So you, in principle, you should write it. You should say that we draw the median AM. Okay, so, and then you need to think how this might help you to prove what you need to prove. That is this one. I don't think it's that hard. I just want to wait for you, because I mean that you can see the solution and understand. The point is that you need to come to an idea yourself. Now, can you see it now?
Yes.
Okay.
So
Okay,
I think
now
I started like you, and then since we can know that AM is equal to BM and MC.
So let me write what you say. So you are saying that AM is equal to BM.
BM and
this is what
MC.
we learned in the previous session, yes? So AM, he is saying, is equal to BM, yes?
I think it's more relevant for MC.
Yeah, it's better to say MC, yes, you're right. So let me clean it and write MC here. Okay, so then...
And then we know the angle opposite to C
yeah,
is
you mean
also
this
15.
Yeah, you mean this angle is also 15, yes? Because now, if this one is equal to that one, this means that this triangle is an isosceles triangle. And because this is given to be 15, this also has to be equal to 15. So then this means that this implies that the angle MAC is also 15 degrees. Okay, so let me write with a different color there what we get. So let me write, for example, with this red one. So we realize that this angle is also 15 degrees. And then
the top angle is 150 and the angle beside is 30 degrees.
So this is 150, yes, and then this becomes 30 degrees. Is that okay with everyone? Yes, because the sum of the angles is supposed to be 180. This is 15, this is 15. So what is left here is 150, and then what is left for this next one is 30 degrees. Yes?
And then because the angle by H is 90, the angle by A will be 60.
Yes.
And then we know that in a triangle with 30 and 60 degrees, then AH will be half of AM. So AM will be equal to 2 AH.
Yeah, exactly. So you are using two theorems now. You see, now we have a right angle triangle. This is the right angle triangle. And we know that one angle is 30 degrees. So the side opposite to that is equal to the half of the hypotenuse. The hypotenuse of this triangle is actually AM. Yes. So then because now this angle AMH is equal to 30 degrees, you can conclude that AH is equal to half of AM. Yes? But now, can you finalize the problem, finally?
So then, since AM is equal to BM and MC.
Yes, we just mentioned that. Do you remember I told you that the median corresponding to the hypotenuse is half of the hypotenuse itself. So it means that, on the other hand, we know that AM itself is 1/2 BC. Now, if you combine these two, AH becomes equal to 1/2. This is 1/2 that I put here. And instead of AM, I put 1/2 BC. And then if I multiply these two 1/2s, it means that AH is equal to 1/4 of BC. Okay, so you see, based on what we learned before and combining two problems into this one problem and a little bit of previous knowledge that of course if these two sides are equal, then this is 15 as well, and then the sum of the angles is 180. So using those ideas that we already know and combining the previous two problems, we were able to show that in this triangle with acute angle 15, the height is a quarter of the hypotenuse. Any questions here? You see that this is the nature of geometric problems. You really don't know where to start with. You need to be a little bit creative, okay? But of course, you can increase this skill by practicing a little more. Okay, so if you don't mind, let us go to the next question. And I want you to read it, so I can read it for you. So prove that in any right angle triangle, the bisector of the right angle also bisects the angle between the median and the altitude to the hypotenuse. I don't think it is hard to understand what the question means, but if you don't understand it, we can come and draw the picture, make it a little bit clear for you. Yeah. So yeah, try to read the question and try to draw some nice picture for you. Sketch a good graph. You really don't need to be very precise because it is just time consuming. And then try to understand the problem and get an idea. And if you found the idea, please just talk to me so that I can ask. We can continue. So if you don't mind, let me just start the problem here. Let us see why you couldn't solve it. Okay, so for example, if I have a right angle triangle, hopefully this will work. Yes, so assume that this is your right angle triangle and this angle is 90 degrees. Okay, so this is A, B, C. Okay, so what we are supposed to show that the bisector of the right angle, so I mean the bisector of this angle, so let us draw it, for example, with a different color. So I need to bisect this into 45 degrees, roughly. If I want to do it with hand, assume that this is the case, okay? So let us consider this. And then usually this is denoted by D. Okay, we want to show that this bisector that divides this into 45 and 45 also bisects the angle between the median and the altitude to the hypotenuse. Okay, so it means that if I draw the height or the altitude of this to the hypotenuse, which is this one probably. Yes, so this is 90 degrees. Let me call this one H. And if I draw the median, let me change my color. If I draw the median, if I find the middle point, say, for example, 10, 11, 12, 13, 14, 15. So 7, yeah, 1, 2, 3, 4, 5, 6, 7.5, somewhere here, for example. If I draw the median as well, let me denote it by M. We want to show that this one, which was bisector of the angle, 90 degrees angle, also bisects this angle. Could you at least understand what is the meaning of the question? Could you come to this conclusion as well by reading this text?
Yes.
Yeah, so that's the point. Good. So it means that we need to show that these two angles are also the same. So in these kinds of problems, because we really don't know where we should start with, what I do usually try to put names for my angles. So let me call this angle, for example, here X. Let me call this angle Y. My point is to show that X is equal to Y. Okay. Okay, so we want to show that. I don't know, do you have any idea how you thought about the problem?
I tried to say, suppose that X is, suppose that Y is X, and then
It's not a good idea, yes. It's not a good I'm not saying this is totally wrong, but I don't prefer to do that because you want to see, assuming that this, where you, so I will follow more or less your idea, but I would say that, okay, let me call, for example, this one T, this angle here, let me call this angle here, T, for example, I don't know, let me call this angle here Z, yes. So I would say what I know is this. I know that angle x plus y, angle x plus t is 45. Angle z plus y is also 45. So it means that these two are the same. So this is something that I exactly know. Do you agree with me? Because x plus t is this angle, which is 45 degrees, and y plus c is this angle, which is 45 degrees. And I know that I am going to get this. So it's more or less your idea, but Donnet, I think this is a better way to do it. So you want to prove that x is equal to y. You can prove this if you can prove t is equal to z. So this means that now you focus on proving that is it the case that t is equal to z, because you realize that if you can show that somehow t is equal to z, then t and z will be eliminated from the sides of this equality and you get exactly what you want to show. This is your question mark. So it means that might be it would be a good idea if I can focus to talk about these two. The chances of saying these two are equal, I think, is a little bit higher. Why? Because, for example, you know something about this angle. This angle is complement to this angle B. And this angle and that angle are related to this angle. Yes? So by the way, do you know, if I ask you, if I call it alpha, do you agree with me that alpha is equal to z plus c? This is something that we learned in Math 2C. You might have forgotten. This is called the exterior angle or an external angle of a triangle, yes? So if you have forgotten that, let me just remind you here. If you have any triangle, say this, and then you have A, B, C. If I continue one of these sides, say here, and this angle that is here is called an external angle or an exterior angle, okay? This is an exterior angle to this angle, okay? So if I call this one, I don't know, alpha, then if I call this one U, V, W, it's clear that alpha plus W is 180. It's also clear that U plus V plus W is 180. So it means that alpha plus W is equal to U plus V plus W, and this W is cancelled from both sides, and then you get this conclusion that alpha is U plus V. Actually, we used this in the previous session as well. So what does it mean? It means that if you have an exterior angle, the size of this angle is the sum of two internal angles which are not adjacent to this angle itself. So this external angle has an internal angle adjacent to it. If you forget about this, there are two more internal angles. If you add them, it becomes equal to the size of this exterior angle. Okay, so that's a very important thing. So for example, here, if I have this situation, my triangle might be something like this. If I have this as my triangle, then for example, if I call this alpha, if this is U and this is V, still alpha is equal to U plus V. So you need to train your eye to catch these things. So is that clear that that's the same story? Alpha plus this angle W is 180. U plus V plus W is still 180. For the same reason, I can come to this conclusion that alpha is equal to U plus V. So we learned that any exterior angle of a triangle is equal to the sum of the angles, sum of the internal angles that are not adjacent to that external angle. Yes? So here I was talking about the chances of proving this. So for example, if I call this one if I call this one alpha, yes, then I hope that you immediately realize the connection between this alpha and this z and this c, according to this rule that I told you, because this alpha is an exterior angle of this triangle. Yes? Yes? And now let me ask you something. What can you say about, do you agree that this sum is also equal to b? T plus x plus y is equal to b. Do you agree with me here? If yes, say why. Yeah, why this is correct?
Because it's a unilateral, no, what's called, the two sides are the same. AB and AM are.
Yes, according to the theorem that we had so far, yes, because this is the median. Yes, this is the median. It's not equilateral, it's isosceles, yes?
Ah, okay.
Yeah, it is. This is the median, and the original triangle is a right angle triangle, yes? So, and then it means that this length, this is the length of the median, is equal to half of the hypotenuse, and BM is half of the hypotenuse. So it means that AM, so you see, you need to train your eyes. You knew this, but the picture is a little bit more complicated. You should be able to extract the relevant information out of it. So it means that this angle, which is x plus y plus t, is equal to angle B itself. And there is a connection between B and C, and there is a connection between C and Z and alpha, yes? So if you try to combine these relations, it's not that hard. I am completely sure that it will work. And then you immediately show that Z and T are the same. Do you want to think about the problem, or do you want me to solve it for you?
No, I think
Hello?
it's kind of obvious.
No, it's not quite obvious. It needs a little bit of work, but you need to
Okay.
write something down to make it precise. So let me just give you 5 more minutes to finalize the problem. I don't think it's hard now. So this is one lesson. If you haven't seen equality of these two, because the picture is a little bit complicated, so you need to take a lesson that, okay, I need to train my eyes so that I can catch the relevant information out from a little bit more complicated picture. Okay, so okay, let me just wait a little bit, just 5 minutes, to see how you can solve the problem. Okay, so what Malcolm is actually saying, I think, is completely correct. So I just told you that this is equal to that one, but we also, sorry, I told you that this median is equal to that one, but we also know that this median is also equal to this one, yes? So this means that if this angle is Z, this angle is also Z, yes? So then this angle is equal to this angle. Okay, so let us write these things. Okay, so I would say that AM is equal to MC because of what we showed so far. AM is the median to the hypotenuse. So then it means that angle C is equal to Z. Yes? But we know that angle C plus angle B is 90 degrees. Yes? In the original triangle is a right angle triangle. So this is 90. So this means that the sum of these two angles has to be 90 degrees. On the other hand, in this triangle, these two angles are also complementary, because this triangle is a right angle triangle. So T and B should also add to 190. So I would say that in triangle ABH, what I can write, I can say that T plus B is also equal to 90 degrees. So from these two, I can conclude that angle C plus angle B is equal to angle T plus angle B. Then angle B is canceled from both sides, and I realize that angle C is equal to angle T. Yes, so that is what I showed. On the other hand, you see, let us have this one here as well. So if this is number 1 and if this is number 2, from number 1 and number 2, you can conclude that angle Z and angle T are actually indeed the same. Yes. And then what we have this one, so let me put a star here. So then we know from this and from the star that we can conclude that finally angle X is equal to angle Y. So you see the problem, you see this is the nature of geometry. The problems are not that hard, but finding these connections together, these connections needs a little bit more practice. So everyone, are you satisfied that this is a good proof for this?
Yes.
Yeah, okay. Now we have a little bit of time, so let us go to the next problem. So you see this problem in this triangle, triangle ABC. We know that this difference between these two angles is 30 degrees, and the point D lies on AC such that AB is equal to AD. Determine the size of this angle. Okay, so you need to read and draw a good, roughly good picture. You don't need to be very precise, and use this and use that picture to find the size or the measure of this angle. Okay, so I will actually pause the video and wait for you a little bit. So what we want to do here, hopefully you could at least roughly sketch the picture. So here I have a triangle. So let me just see it like this. So I have a triangle ABC, and this angle ABC is ABC means this angle, minus ACB means this angle. So the difference between these should be 30 degrees. So it is reasonable to draw this bigger than this one, yes, because the difference is supposed to be 30. So yes, let us start drawing something similar to what I did here. You don't need to be precise at all, yes, so just draw the graph, but you need to respect a little bit that this one is bigger than the other one. Okay, so here is A, B, and C, and then we know that this angle minus this angle is 30 degrees. Okay, and we now find a point D on AC such that AB and AD are equal. So it means that whatever AB is, I draw another line in my head here so that the lengths are the same, and then I will call this D. So D is on AC such that AD is equal to AB. Yes, so this means that I can have, for example, as I told you, AD somewhere here, roughly. So you don't need to be very, very precise in your sketching. And then we are supposed to determine the size of this angle CBD. So CBD. So this motivates me to draw this line BD, and then I am supposed to calculate this angle. Okay, so let me just finalize it by drawing this line. Okay, so my question mark is here. So let me call this angle, which I don't know, to be X. My point is to find this angle X. Okay, now do you have any idea how to do that? No one?
No, I thought I had, but I.
Oh, it's not hard at all. So it might be you are confused. You are not friend with geometry yet, so that's why I'm saying. So what we know is that this side is equal to this side according to what we have defined, yes? So this means that if I call this angle, I don't know, Z, I can call this angle also Z. Agree? Because this triangle ABC is an isosceles triangle. AB is equal to AD. Okay, and just we learned that. So if I ask you, how can I translate this? here. So let me give another name to this one as well. So let me, for example, call this angle T for simplicity. And then what we know is that this relation holds. So instead of angle ABC, which is this angle, I can write x plus z. So let me write it for you here. Angle ABC minus angle ACB is equal to 30 degrees. So instead of angle ABC, which is this angle, I put x plus z. This becomes x plus z. And then minus, instead of angle ACB, I put t. Angle ACB is angle t. Yes, so I put t here. And this is 30 degrees. Yes, so I know that. But I just told you, remind you, what is the name of this angle with respect to this triangle?
The outside angle.
Yes, this is the exterior angle. So the size of this angle is the sum of these two non-adjacent internal angles, x and t. Yes, so I can write that z is equal to x plus t. And now you remember that you are supposed to calculate x. So this means that z minus t is equal to x. And now here, instead of z minus t, I can replace x here. Yes, so this implies that x plus x is 30 degrees. So this means that 2x is 30. And finally, x is 15 degrees. That was quite simple, wasn't it?
Yeah.
Okay.
So are all these questions once you like?
Yeah, but this was a little bit, that was much simpler than the previous one. I don't know. That was my mistake that I put this one as the third question. I in principle should put it as the first question. Okay, so we have a little bit of time, at least we can start. By the way, I will upload these lecture notes onto this Google Drive. So there are one problem here, 2 and 3, yes, 3 more problems left. I don't think we have time to solve all of them, but it is a good idea whenever you have free time, just start thinking about those problems. Okay, so let me read this problem for you. In the following figure, AF, which is this one, is the bisector of angle CAD. So it is the bisector of this angle. And BF, which is this one, is the bisector of CBE, bisector of this angle. Prove that the measure of angle AFB, meaning this angle, we want to talk about the measure of this angle. Show that this is the average between the measures of the angles AEB. So it means that if you want to find this angle, this is the average between this angle here, AEB, and BDE. So in other words, we want to show that if I give you this, and I ask you what is this, you just add this and divide by 2, you will get this angle. We want to show that this is not a coincidence. If you respect what is given in the problem, this angle that you get is always the average between these two angles. Okay, we have 8 minutes so that the lesson finishes. So I will stop here and I'll let you think. If you can come up to an idea before that, I can hear you. Otherwise, I really recommend you, when I uploaded these lecture notes onto the extra material Google Drive, you go there and then try to think about them every now and then until next week. Okay?